Okay, today we will first do the concept on formation of image. Okay, we will do the concept on formation of image. First, we will study about concave mirror. We'll study about concave. Okay, tell me one thing. Suppose this is the principal axis. Okay, and rays of light are coming parallel to the principal axis and they are falling on the mirror. Find out where the image will be formed. See, in this case, when the rays of light will fall on the surface. So we have done one thing. We have seen that anywhere where a ray of light forms, we draw a tangent, right? And we always know that there is a normal that passes through the center and it will make an equal angle and the ray of light will pass from it, right? In the same way, in all of the cases, you can draw the same diagram and you can see that the rays of light will move in this direction. It can also move in this direction. It can also move in this direction. Is that clear? That means all of the rays of light which are parallel to the principal axis after reflection will move through a point, right? This point is known as focus of a concave mirror. Is that clear? What is this point known as? Focus of a concave mirror. Okay. Now can you tell me one thing? Suppose I draw the same mirror and I have the principal axis. Suppose I draw the same mirror and I have the principal axis here. Okay. Let this be the center of curvature. Let this be the focus. What will happen? If rays of light emerge out from the focus, and fall on the surface of the concave mirror, what will happen? Draw the diagram first. What is happening is that in this diagram, can we say that this is our tangent? Now, a line joining the center of curvature and the tangent is our normal. So if this ray falls on this will be the incident angle. So if this ray refracts, it will refract at some angle like this, making the same angle. Is that clear? Okay, so if we see all of them, we will find out some rays moving out in this way. So these rays are parallel to the principal axis. That means we conclude two things. First thing is rays of light parallel, rays of light. Okay, we conclude that rays of light parallel to the principal axis, after reflection in a concave mirror passes through the focus. Okay, rays of light parallel to the principal axis after reflection in a concave mirror passes through the focus. Okay, and in this case, what do we conclude? Can we say the rays of light emerging out from focus after reflection passes parallel to the principal axis? Can we say that? Rays of light emerging out of the focus rays of light emerging out of the focus after deflection passes parallel to the principal axis. Can we say that? Okay, so in this case, rays of light emerging out of the focus after reflection passes parallel to the principal axis. After reflection passes parallel to the principal axis. Can we write this one? Okay, I'll give you the next work. Okay, you have written this one? Okay, I'll give you another work. Do this one. Suppose you have a convex mirror now. You have a convex mirror and this one is your principal axis. Okay, this one is your principal axis. Let this point be the center of curvature. Okay, what is happening? Some rays of light are coming parallel to the principal axis and they are falling on the surface. They are coming parallel to the principal axis and falling on the surface. Tell me what will happen in this case. Okay, like previous one, in this case also we will draw a tangent, right? We will always draw a tangent. In this case also we will draw a tangent. Now tell me, we also know that the line that joins the tangent and the center of curvature is the normal. Can we extend this normal to this portion? Can we extend that? Okay, if I extend that, will this be our angle of incidence? Then this must reflect back, making the same angle, right? This must reflect back, making the same angle. Is it right? Okay, now if I extend this one, will it reach here? Okay, now if I do the same thing with the second one also, can I do it in this way? Can I do it in this way? Okay, if I can do it in this way, can you tell me one thing? That will the angle of incidence be lesser than this one or greater? See, it is greater, right? Okay, then it will reflect, making the same angle of incidence like this. Is that clear? Is the idea clear? That is, so when the rays of light come parallel to the principal axis, they will reflect back, making such a kind of reflection so that it will appear as if, does it appear like the rays are coming out from the focus? Does it appear like the rays are coming out from the focus? Like, see, ignore this portion. Can we say that the rays are coming out from the focus? Can we say that? That means, in case of convex mirror, if parallel rays come and fall on the surface, it will appear that the rays of light has diverged out from the focus. Is that clear? So write down, when parallel rays of light fall on the convex reflecting surface, convex reflecting surface, they reflect or they diverge out, they appear to diverge out from the focus. Is that clear? Is the concept clear? Okay, now if I give you a diagram like this one, suppose this is my convex mirror and suppose this is the principal axis. Okay, what will happen if this is the focus? If this is the focus, and try to understand what I am telling. If the rays of light come such that it is aiming towards the focus, you got my word clearly? It is coming such that it is aiming towards the focus. It is coming such that it is aiming towards the focus. What will happen? Can you draw a diagram for me? Try it now. See, first let us think about center of curvature. Okay, what did I tell you a little ago? That center of curvature has a distance twice than that up to f, right? So see, whenever a ray of light will fall, we need to draw a line up to the center of curvature, right? And that line is always normal. That line is always normal. Now, if this one makes an angle of I, it must get reflected back, making the same angle I. It must get reflected back, making the same angle I, right? Okay, now if this also happens, then what will happen? See, can we draw a normal like this? Right? Now this one also, after reflection, will move. After reflection, this one also will move in this direction. Is the idea clear? Now, what will happen with the last case? See, can we draw in this way? Can we draw? Then this one will be the angle of incidence, right? That means they will get reflect back, making the same angle. So this one will also be the angle of incidence. And for this case also, it will reflect, making the same angle. Is the idea clear? Okay, that means if the rays of light converge towards the focal point of a convex mirror, what happens? After reflection, they will move out parallel to the principal axis, right? See, all of these rays which are emerging out, they are parallel to the principal axis. So, can we write, when a beam of light falls on a convex reflecting surface, such that it converges on the focus, then after reflection they will pass parallel to the principal axis. Is the idea clear? So after reflection they will pass parallel to the principal axis. Did we make it clear now? Okay, write this down. Okay, now now we will do the idea of aperture. We did it last day. Today we will do it a mathematical approach. Okay, see, last day I told you that the circular face was the aperture, right? So what did I tell you? That if I have a circular area through which the light will enter, we can consider this area as aperture. Okay, now let us go into a bit mathematical treatment. See, can we say that this is the focal length? Can we take a point and say that it is the focal length? Okay. What is the distance of it from the pole? This much. This is written in short as small f. Is that clear? This is focal length. Focal length is written in small f. Like mass is written in small m, acceleration is written in small a, focal length is written in small f. Is that clear? Okay. Now, can you tell me what is the diameter? What is the diameter of this area? Is it this much? Is this the diameter of the area? Okay, I am writing the diameter as capital D. Which one is greater? Capital D is greater or small f is greater? Capital D. So in this case we found out that D is greater than small f. That is the diameter of the circular surface. The diameter of the circular surface is greater than the focal length. The diameter of the circular surface is greater than the focal length. Focal length means this is focus, this is pole. The distance between focus and pole is known as focal length. Okay, all of you write down focal length. F, which is focal length. Write down, it is the distance between focus and pole. Focal length is the distance between focus and pole. Okay, now our point of interest is, in all of the diagrams or in all of the parts of this chapter, we won't be dealing with a mirror like this. We won't be dealing with a mirror like this. Okay, you don't need to write, take a screenshot and write at home. Understand this. We won't be doing our experiments, or we won't be studying this chapter based on a mirror like this. This is a practical mirror. Okay, now the mirror that we are interested in must have the focal length. It must have the focal length greater than the diameter. Now how shall I draw that? Okay, can I take a small portion out of it? Like, suppose I am drawing the same focal length, same mirror. Understand it carefully. Okay, I am drawing the same focal length, same mirror. What I am doing is that, so is it same mirror? No, it's a little bigger. Okay, I have drawn it. This is our mirror. Now this mirror has a focal length up to this much. So this will be the focal length, this is the pole. Okay, what will happen if I will erase this portion? What will happen if I will erase this portion? Can I erase it? I can always erase it. Then can I also get a circular surface like this one here? A small circular surface. Can I get a small circular surface like this one? So can we draw a circular surface like this? We can draw. Okay, can you tell me what is the diameter of this surface? This much, right? Okay, if I take this diameter as D, what is the focal length? From here to here, what is the focal length? F. Is the focal length greater than diameter? Yes. So we can consider a mirror like this. We cannot consider a mirror like this. Is that clear? Is that clear? Because in this kind of mirror, our images won't take the approximation. We need to work with paraxial rays. What are paraxial rays? Rays which are parallel to the principal axis and very close to the mirror. In this case, we will have marginal rays which will fall here also. Now in this case, if the rays are marginal, then also they will be close to the principal axis. You got the idea? So this is a case of small aperture. Is it clear? Now the best approximation is, suppose you are considering a focal length which is much greater than the diameter of the mirror. This is our best approximation. Is that clear? So whenever we are drawing or we are applying any kind of formula in our numericals based on this chapter, in all of the cases we will assume that the rays which will be coming, they will be very close to the principal axis and the aperture is of small aperture. This is known as small aperture. Is the idea clear? What is it known as? What is it known as? Okay, draw it now. Now, can you tell me that if I tell you to find out the focal length of a concave mirror, can you do that without using the laboratory equipments? Can you do that? If I give you just a simple concave mirror and I tell you to find out the focal length, can you do that? How will you do that? Yeah, close the book, close the book. How will you do that? How will you do that? Okay, we just understood that whenever a ray of light comes parallel to the principal axis in a concave mirror, they converge and meet at a point which we call as focus, right? Okay, suppose I think about this mirror. I'm thinking about this mirror. Okay, now suppose a ray of light is coming and falling on this mirror. Okay, suppose a ray of light from a distant object, suppose a ray of light from a tree very far away is coming and falling on this mirror. Can it fall? Yes, it can fall. Now what I'll do is that I'll take a piece of paper. This is a piece of paper and I will move this piece of paper close to or away from the mirror. I will be able to see the image of the tree. Okay, what I'll be able to see? I'll be able to see the image of the tree. The image of the tree will look like this. Okay, it will look inverted, it will look like this. Now some position will come where the image will be sharp. Suppose when I bring it to this position, I find out that the image at this position is sharp. Is that clear? That means if this tree is very far away, it can only happen when the tree is very far away. Otherwise, we can't do it in this way. Okay, this position will be the focus. Is the idea clear? Is the idea clear? Why? Because we will imagine that a ray of light parallel to the principal axis is coming and falling on the focus or falling on the surface and it is getting reflected and the image is formed here. Is that clear? Okay. Now, let us do another thing. When you go home, you need to screenshot it and draw them and show it to me the next day. Okay. Now, let us imagine a setup. What kind of setup? See. Suppose this is our concave mirror, okay, and the line from the center of the mirror, this is the principal axis. What I am doing is that I am using a plank, a wooden plank, and I am placing the wooden plank here. Can I place a wooden plank here? Like
takta, I am placing a wooden plank here. Shall I show it 3D or 2D? You can understand it 2D, right? Okay. This is the wooden plank. Now, suppose I keep an object or a bulb. Suppose I keep a bulb in here. Light will come out from the bulb. Now if we move a paper placed at the bottom of the plank, what is that paper? The paper is placed at the bottom of the plank, and if I move that paper, I will see that depending on the position of the bulb, I can move the bulb also, I can move the paper also. The depending on the position of the bulb, the position of image on the paper will be sharp at different positions. Suppose when the bulb is here, suppose the image is sharp at this position. Okay. Now suppose I move this bulb to this position. Okay. Then I'll see that the image is not sharp here. I'll take it away from here, and at some point away from the bulb, the image may be sharp here. So we need to understand that depending on the position of the bulb, the image of the bulb is changing its position. We can get an image anywhere, but image will be sharpest at this position, right? The point where the image is sharpest is the actual position of the image. Okay. Now we will call this one as object, right? We will call this one as image. Is that clear? And for the image to form, we will draw rays of light that will fall and that will make this image. We will draw rays of light that will fall and which will form this image. Okay. Now every time we won't be drawing a so big diagram like this. We will be using it diagrammatically. Like we will be using short symbols and we can understand the thing. Okay. Okay. First is rules of image formation. Rules of image formation. See. Rule number 1. We have already done this one. Rule number 1 says that if there is a concave lens and let this be the pole, if a ray of light is incident parallel to the principal axis, then after reflection it passes through the focus. Okay, write down the first point. If a ray of light is parallel to the principal axis, then after reflection it passes through the focus. If a ray of light is incident parallel to the principal axis, then after reflection it will pass through the focus. Light incident parallel to the principal axis after reflection passes through the focus. Clear? Now rules for concave. First we will do the set of concave, later on we will do the set for convex. Okay, rule number 2. Rule number 2. Suppose you again have a concave mirror. Now in this case, suppose the rays of light are emerging out from the focus. We know this one. What will happen? What will happen if a ray of light emerges out from the focus? It will pass parallel to the principal axis. So remember rule number 2. Rule 2. if a ray of light emerges out from the focus, if a ray of light emerges out from the focus, it will pass parallel to the principal axis. It will pass parallel to the principal axis. Is that clear? Now we will do rule number 3. Rule number 3. See, what does rule number 3 tells us? Rule number 3. Suppose a ray of light comes and falls on the pole. Why did the ray of light fall? On the pole. Then, if the ray of light comes and falls on the pole, this will be the angle of incidence, right? It will pass making the same angle with the principal axis, right? That means rule 3, if a ray of light falls on the pole, it reflects back making the same angle with the principal axis. It reflects back making the same angle with the principal axis. Done? Yes, tell me. Now we will do rule number 4. Rule number 4. What does rule number 4 tells us? Suppose we have another concave reflecting surface. Okay, now in this mirror we will again draw the principal axis. Okay, see, suppose a ray of light emerges out from the center of curvature or passes through the center of curvature. So if this ray of light will pass through the center of curvature and fall on the surface, it will get reflected back, but it will get reflected back along the same direction. Is that clear? Yes, because we know this already, that this will make the tangent, this one will be the normal. Any ray coming towards the normal will be reflected back along the same line, because the angle of incidence will be 0 degree, because it will be perpendicular to the surface. That means angle of incidence will be 0 degree. Is that clear? Is the concept clear? Okay, so write down that rule number 4. Rule 4. If a ray of light falls on the concave mirror, if a ray of light falls on the concave mirror, passing through the center of curvature, after reflection will trace the same path. After reflection will trace the same path. If it comes in this way, after reflection it will go back along the same path. Is the idea clear? Done? Okay. Now we will do the rules of image formation in convex mirror. In convex mirror. Okay. Okay, you don't need to write this. We will just draw the picture. We'll draw 4 pictures in one frame. Okay. This will be rule number 1. This is rule number 1. This is for rule number 2. This is for rule number 3. This is for rule number 4. Okay. You can draw it the other, okay, as you are new, you draw it in this way, otherwise you will face problem. Okay, draw it in this way, otherwise you will face problem. Okay, done. So let us draw the principal axis in each case. We will draw the principal axis in each case. Okay. This is the principal axis. This is pole, this is pole, this is pole, and this is pole. Okay, all of you, look at the board. Now, if a ray of light comes parallel to the principal axis, we know what will happen. After reflection, it will move out such that it has diverged from the focus, right? So after reflection, it will move out, and it will move out such that it has reflected from the focus. Is that clear? Okay. If a ray of light comes towards the focus, what will happen? If a ray of light comes towards the focus, comes aiming towards the focus, what will happen? Yes, after reflection, it will move out parallel to the principal axis. Is that clear? Okay. Rule number 3, if a ray of light falls directly on the pole, can it fall in this way? Yes. It will make an angle I, then it will reflect back, making the same angle I. Is that clear? And if a ray of light falls on the surface of the mirror such that it is aimed towards the center of curvature. What does that mean? Suppose this is aimed along this direction, right? It is aimed towards the center of curvature. Then after reflection, it will move back along the same line. So, are all the 4 cases clear? So for a convex, we did this one. For concave, we have done in the previous one. You don't need to write all of them. Can you understand it? Okay. We will draw some image formation. Now, yes. Now, image formation. Image formation in concave mirror. Okay. First we will do the first case. Suppose this is our concave mirror, and suppose this is our principal axis. Okay, is it clear? Okay. Remember, whenever you are trying to draw, you need to label all the parts. That's a very important factor. Okay. First we will label the pole. Done. We will label the aperture M dash. Done. We will label the focus. Done. Now remember, when you label the focus, the center of curvature will have the double distance. So this will be center of curvature. Is that clear? When you label the focus, the center of curvature will be double distance. Okay. Okay. This is the basic thing. Now our first case is object. The position of object is at infinity. An example will be, suppose a ray of light is coming from stars, not from sun. From where is it coming? Stars. So example is rays of light coming from star. Is that clear? Okay. Remember, whenever rays of light will come from star, however you turn your concave mirror, in whichever direction you turn your concave mirror, the rays will always will come parallel to the principal axis and fall on the mirror. It will always be parallel to the principal axis, and if each ray is parallel to the principal axis, then they are also parallel to each other. Suppose the first ray which is coming is parallel to the principal axis. The second ray which is coming, that is also parallel to the principal axis. It means that both of them are parallel to the principal axis and both of them are parallel to each other. Okay. Now after reflection, we know if the rays of light come parallel, after reflection they will pass through the focus. If this ray also comes parallel, after reflection it will also pass through the focus. Right? That means, where will the image be formed? Here. Always remember, image is always formed where the two rays actually meet or the two rays appear to meet. There are two cases. First case is a real image. What happens in a real image? The two rays actually meet. See, they after reflection has actually met there. We have done reflection in mirror also. In that case, we have extended the reflected portion and then we have cut them at somewhere else. In that case, they have not actually met. The extended portions have met. That is a virtual image. Is that clear? So if they are meeting actually, then this will be a real image. Now, case 2, virtual image. What is a virtual image? The two rays meet when extended backwards. The two rays meet when extended backwards. We have done it in mirror. Suppose this is a mirror and this is a point. A ray of light is coming and going in this direction. Another ray is coming and going in this direction. Now we extend them and they meet at a point. This is known as virtual image. Do the rays actually meet? No. The rays actually diverged. Do the rays actually meet? No. What happened? The rays diverged. We extended them and the extended portions met. We extended them and the extended portions met. They didn't meet. So this is a virtual image. Is that clear? And if they actually meet, in this case it will be a real image. Okay. Now let us see the real image properties. Image properties. Okay, see. So first thing is the image real or virtual? Real. So first thing is the image is real. Okay, can you tell me the position of the image? Where is the image? Focus. The image is at focus. So the image will be at focus. Is that clear? Okay, can you tell me what is the size of the image? It is at a point on the principal axis, right? It is just at a point on the pin. Suppose I am showing you two diagrams. In one case, the rays of light are coming and suppose they are meeting here. Okay? And in one case, the rays of light are coming and they are meeting here. Okay? There are two scenarios. In one case, they are meeting here. In one case, they are meeting here. Now, in the first case, this will be the image. Is that clear? In the second case, this will be the image. Why? Because the image is taken from the principal axis. So what is its distance from the principal axis? It has some distance. Does it have some distance? No. That means the image is a point, right? So it is also a point. That means the image is diminished to a point. Diminished to a point. Is that clear? Okay. Now, so we got it real, we got it as at focus, it is diminished to a point. Okay, now suppose this is ray A, this is ray B. Let us trace this ray. A. So this one is A. B. This one is B. What happened? If it is like this, after reflection, it got inverted. If it is like this, then after reflection, it got inverted. So what will happen at this position? Are they getting inverted here? Are they getting inverted here? Is the image inverted? Yes. So it is diminished to a point and it is inverted. Is the idea clear? Is the idea clear? All of you, is the idea clear? Okay. Now let us do the. So we did the case when the object is at infinity. Now we will do when the object is very far away, not at infinity, it is very far away. Suppose a light is coming from moon, a light is coming from Saturn, a light is coming from sun, then it is very far away, but it is not at infinity. Is that clear? Okay. What will happen in that case? Let us see. Okay. Now this one we will enlarge the mirror a little bit. Okay. Now see. This is our focus. Okay. Now where is the object? The object is very far away, like light coming from moon, light coming from sun. Okay. Now you need to remember, in this case the rays of light will fall on the mirror. The rays of light will be parallel to each other but not parallel to the principal axis. What did I say? Repeat after me. They will be parallel to each other but they won't be parallel to the. Repeat after me. They will be parallel to each other but they won't be parallel to the. They will be parallel to but not parallel to the. Okay. Now if the rays are parallel to each other, can I drop some rays? Can I drop some rays like this? Can I drop them like this? Okay. Now after reflection, we know when a ray of light falls on the pole, it gets reflected making the same angle, right? Now this will also get reflected in this way. Okay. See, the image is not at the focus but the image is somewhere along the line of the focus, right? It is not actually a line, it is a plane. What did I say? What is it? It is a plane. Now this plane is known as focal plane. What is it known as? It is known as focal plane. Okay. So the image will be formed somewhere on the focal plane. So when the ray of light comes parallel to each other but not parallel to the principal axis, we will see that the image is formed on the focal plane. Okay, tell me, are they real? Are they real? Do they actually meet after reflection? They actually meet after reflection. Are they the dotted lines? No. Have we extended the reflected portion? No. So they have actually met. That means, are they real or virtual? Real. Clear? Okay. Tell me, suppose the size of a moon and the size of this image, which one is less? This image is less. So it will not be diminished to a point but it will be diminished. Is that clear? So the image will be diminished. Okay. Where will the image be formed? It will be formed on the focal plane. Right? Okay, is the image inverted? Yes, the image is inverted. Is the idea clear? Do you understand it properly? Is there any doubt? Okay. Today we will do only up to this one. Next day we will do the other diagram. First you need to practice each of the diagrams, and next day bring all of the diagrams that we did today by doing each diagram 6 times. How many times? 6 times. And remember, you have to use scale, compass and pencil. No pens. Is that clear? Scale, compass and pencil. Clear? Okay. That is all for today.